Some minds do not quiet easily. They do not need less. They need something precise enough to follow. Tonight, the archive offers not an answer, but a structure, a place for thought to move more slowly. The lights are off in the laboratory. The bench runs the length of the room. The glassware on the shelves above it has been there since the afternoon, since the last person left, since the door was closed. Some of it is clouded, not all of it. The flasks near the window are clearer than the ones toward the back. The difference is not in the glass. The glass is the same glass throughout. The difference is in what has happened at each surface since the room was sealed. The clouded surfaces have condensation, not visible droplets, nothing that would run or collect. A film thinner than a human hair, of water molecules that have left the room's air and settled against the glass. The glass is slightly cooler than the air. Cool surfaces attract water vapor at the margin, where the temperature difference is sufficient. At each cooled surface in this room, at the micro scale, water molecules are arriving from the air and staying, adhering to the glass, held by the same forces that hold water molecules to each other, settling into a layer that grows thicker by fractions as the night deepens. This layer scatters light. A clean glass surface allows light to pass through with minimal deflection. The photons entering the glass at one face, bending at the boundary between air and glass, traveling through the material, bending again at the exit face, and continuing on. The path is predictable. The glass is, in this sense, transparent, but the condensed film on the cooled flask is not glass. It is a water surface, irregular at the microscale, not flat, not uniform. A surface made of molecules in slightly different orientations held against the glass by their attraction to it and to each other. Light reaching this surface does not find a single boundary. It finds many. The air, then the upper surface of the water film, then the lower surface of the water film, then the glass, each boundary at a slightly different angle depending on where in the film the light arrives. Some light passes through, some reflects, some scatters sideways, deflected by a surface irregularity at the scale of the wavelength itself. The scattered light does not reach the eye in the direction the eye expects. The flask appears clouded. The glass has not changed. The surface has acquired a condition. That condition changes the path of light. The cloudedness is not inside the flask. It is at the interface between what the glass is and what the night air has brought to it. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. On the bench, a graduated cylinder holds liquid. The cylinder is glass, narrow, marked along its length with lines at regular intervals. Each line a measured volume, the intervals calculated and etched into the glass at manufacture. The marks are fixed. They will not change tonight or any night. The volume a given mark represents is determined by the diameter of the cylinder at that height, which is a property of the glass itself. The liquid inside does not sit flat. At the wall of the cylinder, where the liquid meets the glass, the surface curves upward, not dramatically, a few millimeters, the curve beginning close to the wall and flattening toward the center of the cylinder. This curvature is the meniscus. It is not a flaw in the liquid or the cylinder. It is the consequence of two competing forces: the attraction of the liquid molecules to each other, which pulls the surface flat, and the attraction of the liquid molecules to the glass wall, which pulls the surface upward where the glass and the liquid are in contact. These forces do not resolve. They coexist as a curve. The glass pulls the liquid up at the wall. The liquid pulls itself flat at the center. Between these two tendencies, the surface settles into the shape that satisfies both as far as either can be satisfied. The meniscus, curved at the edges, flat at the center, the exact shape determined by the ratio of adhesion to cohesion for this liquid against this glass. To read the volume correctly, the eye must be level with the bottom of the curve, not above it. Above, the curved edges appear higher than the center, and the reading is too high. Not below it. Below, the curved edges obscure the center, and the reading is uncertain. At the exact horizontal level of the meniscus's lowest point, the mark behind it is readable and the reading is accurate. The accuracy is not in the cylinder. It is not in the liquid. It is in the relationship between the observer's position, the mark on the glass, and the curved surface of what the cylinder holds. Precision is not a property of the instrument alone. It is a condition that exists when the instrument, the material, and the angle of observation are aligned. Change the angle and the reading changes. The mark does not move. The liquid does not move. What changes is the geometry of the observation. The path from the eye to the mark, through the curved surface of the liquid, to the number the cylinder carries. Precision is not a state sealed inside the glass. It is a position that must be entered. Breath enters, breath leaves. Between breaths, the air holds its density. The mark does not measure the liquid. It measures where the liquid meets the glass. True wisdom cannot be captured in words. It is found only in the silence between them. At the back of the lowest shelf, there is a bottle that has not been moved in some time. The label is faded at the edges where the light has reached it over the years. Not the central text, which was shielded by the shelf above, but the margins, where the paper has yellowed and the ink has thinned. The solution inside is clear. It appears unchanged from what it was when it was prepared. The same color, the same volume, the same transparency. Nothing about its appearance suggests that anything has happened to it. Something has happened to it. The solution is supersaturated. The compound it holds has been dissolved beyond the normal limit. The concentration exceeds what the solvent would accept under ordinary circumstances, exceeds what the temperature and the pressure of this room would ordinarily permit. This is not a stable state in the sense that a crystal is stable. It is a held state. A condition sustained not because the chemistry demands it, but because the conditions that would end it have not yet arrived. A saturated solution has reached the limit of what the solvent will accept. Every position available to the dissolved compound at that concentration is occupied. The solvent is full. If more compound were added, it would not dissolve. It would remain solid, undissolved, present in the liquid, but not part of it. A supersaturated solution has passed that limit. more compound is dissolved than the solvent should hold. This is possible because dissolution is not simply a matter of concentration. It is a matter of nucleation. A dissolved compound can remain in solution beyond its saturation point if there is no surface available for the first crystal to form on. Without a nucleus, a site where the first few molecules can arrange themselves and hold, the excess compound has nowhere to begin. It remains dissolved, not because the chemistry permits it indefinitely, because the condition for ending it has not been met. The bottle on the shelf has been in this state for weeks. The excess does not know it is excess. Each molecule moves through the solution at the rate the temperature allows, colliding, separating, approaching the glass walls, departing. The glass walls of this bottle are smooth, where they were made smooth, and scratched where something contacted them in the years of use. The scratch is too small to see, present as the history of handling, as the record of the metal spatulas and the other glassware and the shelf surface that the bottle has touched. At those scratches, the glass geometry is irregular. At those irregularities, the surface offers what the smooth glass does not. At one scratch near the base of the bottle, it has begun. The first few molecules of the dissolved compound found the surface geometry favorable. The angles of the scratch providing the positions where the forces between molecules could be satisfied, where the arrangement could hold against the thermal motion that would otherwise displace it. They held. A nucleus formed. 2 molecules, then 3, then more arriving at the positions the growing structure offered at its edges. The solution did not change at this moment. The condition changed. A surface appeared that was exact enough to begin. The excess that had been moving through the solution without resolution found the positions it required. The first crystal grew. Its surface provided more positions than the scratch alone had offered. The growth accelerated, not rapidly, not dramatically, but at the rate the concentration and the temperature and the geometry of the growing surface together allowed. What could not remain dissolved became structure. The crystal at the base of the bottle is not large, a few millimeters across, visible as a slight opacity at the lowest point of the glass, a haziness that catches the light differently from the clear solution above it. It is not the compound that disappeared. The compound that was dissolved is still the same compound, the same molecular structure, the same mass. What changed is the arrangement. The molecules that were moving through the solution, distributed evenly, separated by the solvent, are now positioned against each other in the fixed geometry that the forces between them require. The arrangement that the solvent had been preventing, by occupying the space between the molecules, by mediating the forces, is now present where the solvent no longer reaches. The solvent has not left. The crystal has displaced it at the surface where the growth occurred. Breath enters, breath leaves. Between breaths, the air holds its density. The crystal grows slowly in the undisturbed solution. Each molecule that arrives at the growing surface arrives from the solution immediately surrounding the crystal. The solution that has been depleted slightly by the growth. the concentration there lower than in the rest of the bottle. The compound diffuses from the higher concentration of the bulk solution toward the lower concentration at the crystal surface. This diffusion is slow. The rate of growth is limited by the rate of diffusion, by how quickly the compound can move through the solution to reach the surface where it will be incorporated. The crystal does not accelerate this. It offers the surface. The surface offers positions. The positions are filled at the rate the diffusion allows. Each new layer of the crystal forms when the previous layer is complete enough to provide the geometry the next layer requires. The regularity of the crystal, the flat faces, the precise angles, the geometry that repeats at every scale is the consequence of this process. Each molecule taking the position the forces require, each layer building on the one before it, the structure extending outward from the first nucleus in the direction the forces permit. The flat faces are not imposed on the crystal. They are the outermost expression of the internal arrangement, the pattern that began at the nucleus, propagating outward until it reaches the boundary where the solid ends and the solution begins. Each face is parallel to a plane that runs through the interior at the same angle, at every depth, all the way to the scratch at the center. The exterior is the interior, made visible at the edge. The scratch that provided the first nucleus is inside the crystal now. The growth has surrounded it. The layers that followed the first nucleus have built over it, incorporated it into the interior of the structure, covered it with the faces that the subsequent growth produced. The irregularity that started the process is no longer at the surface. It is at the center, enclosed by what it initiated. The bottle is dark in the laboratory. The solution above the crystal is still supersaturated, depleted slightly near the crystal surface, still holding more compound than it should in the rest of the volume. The crystal at the base is still growing, still incorporating the molecules that diffuse toward it, still adding the layers that the arriving molecules provide. The faces of the crystal are not finished. The geometry is not complete. The solution was not disordered. It was holding more than it could hold indefinitely, without the surface that would let it begin. The excess was not a failure of the solution. It was the condition of the solution, the state it was in while the precise enough surface had not yet arrived. When the surface arrived, the excess did not disappear. It did not dissipate. It took the arrangement the surface made possible, and the arrangement is still here, growing at the base of the bottle, adding to itself at the rate the undisturbed solution and the night temperature allow. In the still laboratory, the crystal continues to grow. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. The bench is empty. The flasks on the shelves above it hold their surfaces. The clouded ones still clouded, the clear ones still clear. The condensation film present where the glass is cool, absent where the glass has held the room's temperature. The graduated cylinder holds its liquid, the meniscus curved at the walls where the liquid meets the glass, flat at the center where the cohesion of the liquid pulls it level. The bottle at the back of the lowest shelf holds its crystal, the faces forming in the dark at the rate the diffusion determines. The condensation on the flask surface is arriving molecule by molecule at the rate the temperature difference permits. The meniscus in the graduated cylinder holds the shape the forces require, not tending toward another shape. The crystal in the bottle is growing at the rate the solution concentration and the surface geometry and the temperature together allow. These processes do not share a scale. The condensation film on the flask is a thickness of molecules, a few hundred molecules deep at most, the scale of nanometers, the scale at which individual molecular events are still meaningful. The meniscus in the graduated cylinder is a surface of millimeters, visible, measurable with the naked eye, the scale at which the forces between millions of molecules produce a curve that a human observer can read. The crystal at the base of the bottle is a structure of millimeters growing from a nucleus of nanometers. The two scales connected by the process of growth. The molecular arrangement at the center, propagating outward through the layers to the faces that are visible now. The same laboratory holds all three, each in its own scale and speed, each governed by the same forces expressed at a different magnitude. The condensation does not know the meniscus is present. The meniscus does not know the crystal is forming. The crystal does not know the condensation film scatters the light that would otherwise illuminate it. They proceed in the same room, in the same night, at the speed the current conditions require and no other. The scratch that started the crystal is at the center now. What came after it? The layers of the compound arranged in the geometry the forces require, the faces that formed as each layer completed and the next began, surrounds it on all sides. The scratch is not visible. It is present as the reason the crystal exists at this location rather than another, as the cause that the effect has now enclosed. The surface that was precise enough to begin is inside the structure it began. The crystal at the base of the bottle is still adding to itself. Breath enters, breath leaves. Between breaths, the air holds its density. When night falls, the archive remains. Some minds do not quiet easily. They do not need less. They need something precise enough to follow. The archive offers not an answer, but a structure, a place for thought to move more slowly. On the table, in the dark, the tuning fork has not been touched. It rests on the wood at the angle it was set down, the handle touching the surface, the two prongs rising from it, the gap between them fixed by the geometry of the metal itself. The room is quiet. The air in the room is still. The metal is at the temperature the room holds at this hour, cooler than it was in the afternoon. The difference small but present in the way the surface of the prong would feel against a finger. The fork has a particular shape for a reason. Not decorative, functional. The two prongs, the gap between them, the length from the base of the prongs to their tips, the width of each prong at its narrowest point. These dimensions were chosen, worked out in the making of the fork, because they determine how the metal will move when struck. A longer prong moves more slowly. A shorter one moves faster. A wider prong resists more. The proportions of this fork were set to produce a specific response. One particular rate of movement, out of all the rates this metal could be made to move at. The fork has not been struck yet. The potential of its shape is present in the metal. The geometry that will determine the response, the mass at the tip of each prong, the elasticity of the steel. None of this is visible in the dark room. The fork appears as a shape, a silhouette, the two prongs rising from the handle. What it will do when struck is already in it, held in the dimensions the maker chose, waiting not with anticipation, but with the same absence of anticipation that a key holds before the lock. The room is quiet. The fork is on the table. When it is struck, the prongs move. The blow arrives at one point, the outer edge of one prong, where the mallet or the knee or the edge of the table contacts the metal. The force is brief. The contact lasts a fraction of a second, transferring momentum to the prong at that point. Then the contact ends. The force is gone. The metal has been disturbed. The disturbed prong does not stay where the force pushed it. The steel resists deformation. It has elasticity, the property of returning toward the shape it held before the force arrived. The prong that was pushed outward is pulled back by this tendency. It returns toward its original position, carries past it from the momentum it has built, overshoots on the other side, and is pulled back again. Each returns slightly less than the last, the motion repeating in both prongs now, the two prongs moving toward each other, and then apart, and then toward each other again, at the rate the length and width and mass of the metal require. The force lasted a fraction of a second. The motion continues, not because the force is still acting. The force is finished. The motion continues because the metal has the property of returning toward what it was, and it overshoots and returns again and overshoots again, and each cycle brings it back through the position it started from and out the other side. The movement is in the metal now, not in anything still being applied to it. The prong is moving between two positions it never quite reaches. The midpoint, the only place it passes through. The endpoints approached and retreated from in a motion that will continue until the losses accumulate enough to stop it. What was struck is not what is vibrating. The force struck the metal at rest. What is vibrating is the metal in motion, a different state of the same object, entered in the instant of contact and maintained by the metal's own properties after the contact ended. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. The vibration is leaving the fork. At the surface of each prong, the moving metal is in contact with the air. Each time a prong moves toward the air beside it, it compresses the air at that surface slightly, pushes the molecules closer together than they were. Each time the prong moves away, the air expands again. The prong moving back and forth produces a compression and expansion that moves outward from the surface. A wave, carrying the pattern of the prong's motion into the surrounding air at the speed the air allows. The wave moves away from the fork in all directions. It does not take the fork's motion with it. It carries the pattern, compressions and expansions at the same rate the prong moves, the interval the metal holds reproduced in the air, moving outward at the speed the air allows. The fork is losing energy with every cycle. Some goes into the air, into the wave that has moved away and will not return. Some goes into the metal itself, into the small deformations at the molecular scale that the repeated bending of the steel produces, the energy converted there into heat too small to measure. Some goes into the handle, and from the handle into whatever the handle rests against. Every cycle costs something. The vibration is not sustained by anything adding to it. It is sustained by what remains of the initial energy, diminishing cycle by cycle. The prongs moving through arcs that grow narrower as the energy that drives them diminishes. The motion that was entered in the instant of the strike is spending itself. Not quickly. The rate at which it spends itself is determined by how efficiently the fork loses energy to each path, to air, to internal friction, to contact. A fork in still air, resting lightly, loses energy slowly. The fork goes quiet before it stops. What the ear can no longer hear is still moving. The prongs are still tracing their narrowing arcs, the amplitude below what the air can carry far enough to reach a listener. The motion present in the metal at a scale the body near the fork might still detect if it were close enough, if the air were still enough. Breath enters, breath leaves. Between breaths, the air holds its density. When a second strike arrives before the first motion has ended, the prong is not at rest. It is still in the arc from the first strike, smaller now, but present. The second force finds it already moving. If the force arrives at the moment the prong is moving in the same direction, if the push arrives where the prong is already going, the two add. The prong carries the original motion and receives the additional push at the same moment, and the sum determines how far the prong goes on that cycle. If the force arrives at the wrong moment, it works against what is there. The result is smaller, not larger. The outcome depends entirely on when the force arrives, not on how large the force is. The same force, arriving at different moments in the prong cycle, produces different results. Arriving in the right relationship to the motion already present, it adds to it. Arriving in the wrong relationship, it subtracts. The force does not know which it is doing. It arrives when it arrives. The prong receives it as the sum of what was there and what was added. If a series of small forces arrives at the same interval, the prong moves. Each force reaching the prong at the same point in each cycle. Each addition builds on what the previous additions left. The prong carries more from each cycle into the next. The arcs widen. What began as a small motion becomes a larger one, not because any single force was large, but because each force arrived at the right moment. The force was small. The interval was exact. The growth does not continue without limit. Each wider arc also loses more surface moving faster through the air, more energy transferred to the wave, more internal deformation in the metal. The losses grow with the amplitude. a point is reached where each cycle loses as much as the arriving force adds. The amplitude stabilizes there, held between what enters and what leaves, neither growing nor shrinking as long as the forces continue arriving at the same interval. When the forces stop, the losses continue. The amplitude falls again, spending what remains of the accumulated motion at the same rate the air and the metal and the contact allow. The same narrowing that would have occurred from the first strike, now starting from a larger arc. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. On the table, a second object, a wooden box, hollow, open at one end. The top surface of the box is a flat face of wood. The box was made to this shape, these dimensions, for a purpose related to what the fork does. The interior volume and the open end calculated to respond to the same rate of motion the fork holds. The vibrating fork is brought into contact with the wood. The handle is pressed against the surface of the box. The prongs are not touching the wood. Only the handle touches. A single point of contact between the metal that is vibrating and the surface of the wood. The vibration crosses the contact point. At the surface where handle meets wood, the motion of the metal is transmitted into the wood. The handle moves at the rate the prong moves. The same motion, carried through the solid material of the fork from prong to handle. Where the handle contacts the wood receives that motion. The wood surface moves at the same rate, and the larger surface of the wood face moves more air than the narrow prong alone could move. The sound changes, not the pitch. The rate of the prong's motion has not changed, and the rate is what determines the pitch. What changes is the volume, the amount of air being moved by each cycle. The prong was moving a column of air as wide as the prong. The box face is moving a column of air as wide as the box. More air receives the compression and expansion of each cycle. The wave that moves outward from the box is larger than the wave that moved outward from the prong alone. The box did not change the pitch. It gave the vibration more air to move. The box also cost the fork something. Moving the larger face of wood requires more energy per cycle than moving the shrow prong through open air. The fork, now in contact with the box, loses energy faster. The sound is louder. It is also shorter. The same motion that would have lasted longer in open air spends itself faster when the box is present. The energy that accumulated in the metal leaving faster through the larger surface, the wave carrying it away at a higher rate. The box does not add energy. It changes the rate at which the fork releases what it holds. The fork lifts away from the surface of the box. The contact is broken. The box face slows. The wave from the box diminishes. What remains is the fork again. The prong still moving, still at the same rate. The amplitude now lower than before the contact because the contact spent some of what was there. The fork carries what the box left it with. On the other side of the table, a second fork. The same metal, the same dimensions, the same handle, made to the same proportions as the first. Not approximately, not close, but to the tolerance that makes the response identical. The same length of prong, the same width, the same mass. A fork that, if struck, would move at the same rate as the first. It has not been struck. It rests on the table as the first fork rested before it was struck. The handle on the wood, the prongs rising, the gap between them fixed. The air in the room is moving. The first fork has been vibrating for some seconds. The wave it has been producing, the compressions and expansions at the rate the prong moves, has been reaching all surfaces in the room, including the prongs of the second fork. At the prongs of the second fork, the air pressure is rising and falling at the same rate the first fork moves, because the wave carries that rate outward and the second fork is in the path of the wave. Each compression arrives at the surface of the second prong and pushes against it. Each expansion that follows pulls the pressure back. The prong is being pushed and released at the same interval the first fork's motion defines. The second prong begins to move, not dramatically. The force of the air pressure against the metal surface is small, much smaller than a direct strike, but the force is arriving at the same interval the second prong would move at if it were vibrating. Each push arrives when the prong, if it were already moving, would be ready to receive it. The first push starts a motion too small to detect. The second push arrives as the prong completes its first cycle and arrives back at the position to receive more. The third push adds to what the second left. The amplitude grows. The second fork is answering, not because the force was large. The air pressure at that distance from the first fork is small, far smaller than a strike would deliver. The second fork is moving because the force arrived at the right moment. Each small addition found the prong at the right position to receive it. The accumulation of small additions at the correct interval produced a motion that grew, cycle by cycle, from a displacement too small to see to one that is producing its own wave in the air. The first fork is struck against the table to stop it. The prongs are held. The vibration in the first fork ends. The wave from the first fork ends. The air in the room stops receiving the compressions and expansions the first fork was producing. The second fork continues. It was not struck. It answered. What it received was small and arrived at the right interval, and the accumulation of those arrivals is now present in the metal as motion, spending itself at the rate the air and the metal and the contact with the table allow, narrowing towards stillness from an amplitude built entirely from intervals rather than force. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. The room is quiet. The first fork rests on the table, held, the prong still. Whatever motion it accumulated, whatever the initial strike built and the subsequent cycles maintained, has been stopped by contact. The metal is returning to the temperature of the room. The small heat produced by the internal friction of its vibration already dissipating into the air, the surface cooling at the rate the still air allows. The second fork is still moving. The amplitude is decreasing. The losses that were present from the first moment the prong began to move are continuing, and nothing is adding to the motion now that the first fork has stopped. The arc the prongs describe is narrowing cycle by cycle, spending what remains of the accumulated motion at the rate the air and the metal allow. What the second fork holds came in pieces, each piece small, each arriving at the interval that allowed it to add to what was already there. No single moment of transfer. A series of arrivals, each one finding the metal ready to receive it, each one adding its fraction to what the previous arrivals had left. The motion now in the metal is the sum of those fractions, not one force, but the accumulation of many small forces that arrived at the right interval. The room holds both forks, the one that was struck and stopped, the one that was not struck and is still moving. The prongs tracing arcs that grow narrower with each cycle, the approach to stillness becoming slower as the motion becomes smaller, the wave still moving outward from the surface of the prongs, diminishing, reaching the walls, and the first fork resting a few centimeters away. On the table, the second fork is still vibrating. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. When night falls, the archive remains. Some minds do not quiet easily. They do not need less. They need something precise enough to follow. The archive offers not an answer, but a structure, a place for thought to move more slowly. The door has closed. The room is dark, not gradually, not by degrees, but as the immediate consequence of the door meeting the frame. Whatever light was present in the corridor, in the space outside, has been cut from this room at the line where the door fits the wall. The room is the same room it was a moment ago. The surfaces are in their positions. The air is the same air. The geometry has not changed. What has changed is the light that was reaching the surfaces and reaching the eye. There is still some light here, not from a source. No lamp is on, no window is uncovered. But the absolute removal of light is not what darkness is in a room like this one. The walls have a surface temperature and emit radiation in the infrared, invisible. The gap at the base of the door admits a narrow brightness from the corridor, spreading along the floor a few centimeters before falling below the level the eye can use. The eye is open. The surfaces of the room are present. The information that would allow the room to be read is not currently arriving in sufficient quantity for the receiving surface to answer. The eye is in the room it cannot yet see. Before the door closed, the eye was in a lit corridor. The surfaces there were reflecting light. The overhead fixture casting its spectrum onto the floor, the walls, the door at the end, the light bouncing between surfaces and arriving at the eye from all directions. The eye was receiving far more than it needed. In bright conditions, the receiving surface of the eye contains a mechanism for managing this excess. The color-sensitive cells near the center, dense and precise, were active, responding to the quantity and spectrum of the light arriving, sending signals at the rate the brightness required. But in that brightness, something else was happening. The molecules in the rod cells, the cells distributed across the wider surface of the retina, the cells that operate at the edge of vision, the cells built for low light, were being changed by the light arriving in excess of what they required. A molecule that can receive light and respond to it was, under that illumination, being converted into a form that cannot, not destroyed, converted. The light was doing to the molecule what light does when it arrives in large quantity, changing its shape, separating its components, leaving the rod cell holding the changed form rather than the form that answers. The eye entered this dark room in that condition. The rod cells, carrying their changed molecules, entered a space where the light was almost nothing, and because the molecules were in their changed form, the threshold, the minimum light required to produce a response, was high. More light than this room contains would be needed to cross it. The eye was present in the room. The room's faint light was arriving at the retina. The retina was not yet able to answer. This is not a failure of the room. The room contains what it contains. The faint brightness at the base of the door is a real quantity of light. Photons arriving at a measurable rate, striking the surface of the retina, carrying the information that the geometry of the room would allow a sensitive enough surface to receive. The room is offering what it has. The receiving surface is not yet in a state to accept it. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. In some minutes after the door closes, something begins. In the rod cells, the molecule that was changed by the light in the corridor begins to return. Not quickly. The process that converts the changed form back to the form that can receive light is slow, dependent on the enzymes that work at the pace the cell's chemistry allows, proceeding at a rate that cannot be hurried by attention or intention or the desire to see. The cell does what it does at the rate it does it. The molecule moves back toward the state in which it can answer. The threshold begins to move, not visibly, not in any way the eye can observe about itself. The threshold is a quantity, the minimum light required to produce a signal. And as the molecules return to their receiving state, that quantity decreases. The rod cells that a few minutes ago required more light than this room contains are beginning to require less. Some of them have crossed back far enough that the faint light arriving from the gap beneath the door is now sufficient to reach them. The outline of the door appears, not fully, a suggestion, the geometry implied rather than stated, the edge of the door against the wall barely distinguishable from the wall itself. The eye is not receiving the door as it would appear in full light. It is receiving the minimum information that allows the door's position to be inferred. The light carrying this information was already in the room. It was already arriving at the retina. The retina, a few minutes ago, could not answer it. Now some of the rod cells can. What appeared is not new light. The room has not changed. The gap beneath the door is the same gap, emitting the same quantity of light it was emitting when the door first closed. What has changed is the receiving surface. A portion of it has returned to a state sensitive enough to detect the light that was already present and not previously detectable. The door became visible because the eye became able to receive less. The cone cells in the center of the retina adapted faster. Within the first minutes, the color-sensitive cells near the fovea, the center of sharp focus, the region of high density, returned to a usable state. Their molecules also undergo change in bright light, also return in the dark, but the process for the cone cells runs faster. By 5 minutes, most of the cone cells have returned to a sensitivity sufficient to operate in what light there is. By 7 minutes, they have reached close to their best condition for this level of illumination. But cone cells require more light than this room contains. Their threshold, even fully recovered, sits above what the room is offering. The faint light at the floor, the dim edge of the door, the almost imperceptible difference between the dark wall and the slightly darker space of the open doorway. None of this reaches the quantity the cone cells need. The cone cells have returned to their best state and still cannot answer this room. The rod cells are still working. Breath enters, breath leaves. Between breaths, the air holds its density. The rod cells require more than an hour to reach their full sensitivity. Their molecules return more slowly. The process that rebuilds them from the changed form to the receiving form proceeds at the pace the cell's biochemistry sets. Not faster because the room is dark, not slower because the room is dark, but at the rate that the conditions of the cell and the availability of the materials the process requires together determine. The rod cells do not know the eye wants to see. They rebuild at their rate. At 20 minutes, the rod cells are considerably more sensitive than they were at 5 minutes. Not at their maximum. That will not be reached for another 20 minutes at least. And even that estimate depends on how much light the eye was exposed to before entering the room, how much the molecules were changed, how far they have to travel back, but considerably more sensitive than they were. The threshold has moved. More of the room is now available to the eye than was available at 5 minutes. The molecule at the center of this is rhodopsin, a protein and a smaller molecule bound together in the rod cell in a configuration that allows it to absorb light. When a photon of the right energy arrives, it changes the smaller molecule's shape, a change that propagates through the protein, triggering the signal the rod cell sends. In bright light, more photons arrive than the rhodopsin can process, and the changed form accumulates faster than it can return. In darkness, with no photons arriving, the changed form slowly converts back. The rhodopsin reassembles from the components the light separated. This is what the dark room is doing to the eye, not acting on it directly. The dark room is not producing the recovery. The dark room is the absence of what was interrupting the recovery. In the absence of the light that was driving the molecules into their changed state, the process that returns them to their receiving state can proceed without being reversed. The recovery is the cell's own process. The room's role is to stop interfering with it. The room has not changed enough to explain what is now visible. 20 minutes after the door closed, the shapes in the room are available. The corner where the wall meets the wall, the edge of the shelf, the form of the chair. None of these are brightly visible. No line is sharp, no color is present. only the spatial relationships between surfaces and the faint differences in how much light each surface holds. But they are present in a way they were not present at minute 1 or minute 5. The room is the same room. The light is the same light. The gap beneath the door is the same gap, emitting the same quantity of light it emitted from the moment the door closed. The walls hold the same faint radiation they have held throughout. The chair is in its position. The shelf is in its position. Not one surface has moved. Not one surface has brightened. What the room contains has remained constant from the instant the door met the frame. The change is in the receiving surface. The rod cells that were not answering at minute 1 are answering now. Not because more light is arriving. The same light has been arriving continuously, because the threshold those cells require has moved below the quantity the room contains. The light was always sufficient. The cells were not yet in the state to be sufficient for it. The room did not become brighter. The eye became able to receive less. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. The rod cells have not finished. At 30 minutes, the threshold is still moving. The recovery of rhodopsin is still proceeding at the rate the cell's process allows. More of the molecules that were changed in the corridor have returned to the form that can answer. The threshold, the minimum quantity of light the rod cells require before they signal, is still decreasing. The full sensitivity of the rod cells, the state in which they can respond to the smallest quantity of light the eye is capable of detecting, has not yet been reached. It will take longer still. The exact duration depends on how bright the corridor was, how long the eye was in it, how far the molecules were driven from their receiving state. A brief exposure in moderate light requires less recovery than a long exposure in bright light. The rod cells in this eye, in this room, are somewhere in that range, still descending toward the threshold that represents their full capacity, still incorporating the return molecules into a receiving surface that grows more sensitive with each one that completes its return. The shapes in the room are more present than they were at 20 minutes, not sharper. The rod cells do not produce sharp images. Their signals are pooled across wide areas of the retina. The spatial resolution they offer is coarse compared to what the cone cells provide in good light, but more present in the sense that the threshold has moved further. That light which was insufficient to produce a signal at 20 minutes is now sufficient, that the room's faint offering is being received by a surface that has become better calibrated to receive it. The room is unchanged. The wall is where it was. The shelf is where it was. The chair holds its position in the space. The gap beneath the door emits the same narrow light it emitted from the moment the door closed. None of the surfaces have moved toward the eye. None have brightened. The room is holding what it has always held in this darkness. The receiving surface is what has changed. The threshold does not announce its position. It is not experienced as a number, not perceived as a line being crossed. What the eye experiences is the appearance of the room, surfaces becoming available, edges separating from the spaces beside them. the geometry of the room arriving in the signal as it crosses the threshold the rod cells currently hold. Each increment of recovery is a fraction of a degree in the minimum detectable, producing no single moment of revelation, but a continuous, slow arrival of what was always present in the room and not yet receivable. The room was always here. The light it contains was always arriving at the retina. The retina was arriving at the capacity to receive it. Molecule by molecule, rod cell by rod cell, the changed forms returning to the receiving forms at the rate the cell's own process determines, indifferent to the darkness surrounding it, indifferent to the eye's desire to see, proceeding because the conditions for proceeding are present and nothing is preventing them. Breath enters, breath leaves. Between breaths, the air holds its density. The dark room holds its geometry. The surfaces have not moved. The distances between them are what they were when the eye entered with its diminished sensitivity and found the room illegible. The chair is the same distance from the wall. The shelf carries the same objects in the same positions. The gap beneath the door admits the same light. Nothing in the room required the eye to recover before offering itself. The room was offering itself continuously, from the moment the door closed, at whatever level of detail the receiving surface could accept. What the eye receives now is not different from what was available at the first minute. It is the same light, the same surfaces, the same spatial relationships. What is different is the surface receiving it, a surface that has been returning in the dark to a state in which less is enough. Less light, less signal, less than the threshold that the brightness of the corridor had required before the room could be read. The rod cells are still recovering. The threshold is still moving downward. The minimum light required has not reached its lowest point. The room is still becoming more available. Not because the room is changing, but because the receiving surface is still changing. The process of return still proceeding at the rate the cell's chemistry allows, still adding to the sensitivity that the previous minutes have already built. At some point, the process will reach its limit. The molecules that can return will have returned. The threshold will have descended to the level the rod cells are capable of reaching. After that, the dark room will not become more available. What cannot be seen at that point will not become visible with further recovery. The limit is set by the cells, by the quantity of rhodopsin they can hold, by the sensitivity the fully recovered rod cell can achieve. The room, at that point, will be read at the maximum resolution the rod cells provide, coarse without color, present as shape and gradient rather than detail. That limit has not been reached yet. In the dark room, the threshold is still moving downward. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. When night falls, the archive remains. Some minds do not quiet easily. They do not need less. They need something precise enough to follow. The archive offers not an answer, but a structure, a place for thought to move more slowly. The glass is in the window frame. It has been there since the window was installed. The same pane, in the same position, held by the same frame. The room behind it is dark. Outside, there is enough light to reach the glass. The faint, ambient brightness of a night sky, the distant glow of a street lamp, the light that no city entirely loses even in the deepest hours. Some of this light passes through into the room. Some of it reflects back into the night. The glass has two surfaces, an outer face in contact with the air of the outside, an inner face in contact with the air of the room. Light entering from outside crosses the outer face first, travels through the thickness of the glass, and crosses the inner face on the way into the room. At each surface, a small fraction of the light reflects rather than continues. Most passes through. The fraction that reflects is small, a few %, but it is present at every surface that light encounters. On the surface of the glass, there is a film, not thick enough to see directly, not a layer that accumulated in a single event, but a condition that built over years. The oils that fingertips left when the window was last opened, the fine particulate the air carries and that adhered in the damp months, the thin residue that forms where glass meets air over long exposure. A film, discontinuous, uneven, a few molecules thick in some places and more in others, the thickness varying across the surface in a pattern no one designed and no one reads. Light reaches this film from outside. At the outer surface of the film, some of the light reflects immediately. Turn back at the first boundary it encounters, the interface between air and the film's surface. The rest continues into the film. It travels through the thin material until it reaches the second boundary, the interface between the film and the glass beneath. There, some of it reflects again. Turn back upward through the film, emerging from the outer surface in the same direction as the light that reflected at the first boundary. Two reflections, one film, both traveling back the same way. The light that reflected from the outer surface and the light that reflected from the inner surface are the same light, the same source, the same character. They diverged at the film's outer surface and have now rejoined, traveling together toward the same destination. But they did not travel the same distance. Breath enters, breath leaves. Between breaths, the air holds its density. Because the molecules were in their changed form, the threshold, the minimum light required to produce a response, was high. More light than this room contains would be needed to cross it. The eye was present in the room. The room's faint light was arriving at the retina. The retina was not yet able to answer. This is not a failure of the room. The room contains what it contains. The faint brightness at the base of the door is a real quantity of light. Photons arriving at a measurable rate, striking the surface of the retina, carrying the information that the geometry of the room would allow a sensitive enough surface to receive. The room is offering what it has. The receiving surface is not yet in a state to accept it. The light that reflected from the inner surface traveled further. It entered the film, crossed to the inner boundary, and returned. A path equal to twice the thickness of the film, added to whatever the outer reflection traveled. This extra distance is small. For a film a few dozen molecules thick, the extra distance is a fraction of a wavelength of visible light. But that fraction is not nothing. Light travels as a wave, not a wave in any material. An oscillation, alternating between states, peaks and troughs, arriving at any point in sequence. Two beams of the same wavelength from the same source that have traveled the same distance will arrive with their peaks and troughs aligned. Peak meets peak. Trough meets trough. They add. The combined wave is stronger. The extra distance does not change the wavelength of the inner reflection. It shifts the position of the peaks and troughs relative to the outer reflection. The two beams are still the same light, still oscillating at the same rate, still carrying the same energy per cycle. What the extra distance changes is only where in the cycle each beam is when they meet. The outer reflection has been traveling a shorter path. The inner reflection has been traveling longer. They left the same source at the same moment and have been accumulating distance ever since. When they arrive together at the film's outer surface, the difference in their accumulated distance is the difference in where they are in their cycle. But if the extra distance the inner reflection traveled equals exactly half a wavelength, the alignment reverses. The inner reflection has completed half a cycle more than the outer. Where the outer arrives at a peak, the inner arrives at a trough. Where the outer arrives at a trough, the inner arrives at a peak. At every point in the oscillation, what one wave adds, the other subtracts. The result is nothing, not diminished, nothing. The two reflections arrive together, each carrying the energy of a reflected wave, and their sum is zero. The reflected light at that wavelength does not exist. Looking at the film from outside, there is darkness at that color, a gap in what would otherwise be a continuous reflection. The light did not disappear. It arrived against itself. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters. Breath leaves. Between breaths, the air holds its density. Where did the energy go? Two waves arrived at the same point, and their sum was zero. But energy does not end. The light entering the film carried energy, and that energy did not vanish when the reflected waves cancelled. What happened at the point of cancellation, in the reflected direction, happened in reverse in the transmitted direction. The light that passed through the film, rather than reflecting, was strengthened at exactly the wavelengths where the reflection was cancelled. The energy moved. What the film removed from the reflected light, it added to the transmitted light. The darkness in reflection is brightness in transmission. The cancelled wave did not end. It continued through the glass, carrying what the reflected path could not carry, because the two reflected waves had met in opposite states and reached zero together. The film does not absorb the light it cancels in reflection. It redirects it. The energy is conserved. Nothing was lost in the cancellation. Nothing converted to heat. Nothing removed from the system. The film's thickness determined only the direction. At this wavelength, at this thickness, The energy that would have been in the reflection is in the transmission instead. This is not a special property of the film. It is what always happens when two waves of the same wavelength meet in opposite states. The cancellation in one direction is inseparable from the strengthening in another. The geometry that produces one produces the other. The film did not choose to redirect the energy. The film's thickness set the condition, and the condition determined both the cancellation and where the energy went. The light is not gone from the glass. It went through. The film on this window is not uniform. The thickness varies. Thicker where the oils accumulated in the seasons the window was opened often. Thinner where the surface stayed clean. Thinnest at the edges where the film dried fastest and left least behind. Across the surface of the glass, the film presents a continuous variation. Not the same condition at any 2 points, but a slow gradient from the areas of greatest accumulation to the areas of least. At each point on the film, the thickness determines which wavelengths cancel in reflection. Where the film is thicker, the extra distance the inner reflection travels is longer, and a longer wavelength meets the half wavelength condition. A color further toward the red end of the spectrum cancels in reflection. Where the film is thinner, a shorter wavelength meets the condition. A color further toward the blue. Moving across the surface, the cancelled color shifts continuously with the thickness, the film carrying a map of its own accumulated depth, written in the colors it removes. This map is not visible at night. The light outside is too faint. The colors reduce to what the darkness leaves. The variation across the glass surface too subtle for the eye to read in this light. But the map is present in the glass. The record of how the film formed and where it is thin and where it is thicker. The complete consequence of years of contact between this surface and the air and the hands that opened and closed it. In full daylight, at the right angle, the map becomes the shimmer of an oil film on a wet street, the colored bands moving across a soap film held to the window. The physics is the same cancellation, the same redirection, the absence made visible by the colors the reflection no longer carries. The shimmer is not decoration, it is information. Each color in the shimmer corresponds to a wavelength being cancelled at that point on the film's surface, which means it corresponds to a thickness at that point, which means it corresponds to the history of how the film built up there. The oil thicker where a hand rested against the glass, the film thinner where the air moved fastest along the surface. The shimmer maps the contact history of the glass, one cancelled wavelength at a time. What is seen in the shimmer is not the film. It is the record of where the film is, written in what the reflection is missing. Breath enters, breath leaves. Between breaths, the air holds its density. A soap film held vertical thins from its own weight. The liquid drains downward, pulled by gravity, accumulating at the base while the top grows thinner. The thinning is continuous. The film thickest at the bottom and thinnest at the top, the thickness changing smoothly along its length. As the film thins, the wavelength that cancels in reflection shifts upward through the spectrum. The map of the thickness visible as horizontal bands of color that rise toward the top as the draining continues. The bands are not static. They move as the film drains, not quickly but steadily, the colors at each height changing as the thickness at that height decreases. A band that was green becomes blue. A band that was blue moves toward violet and then disappears as the thickness passes below the range that cancels visible light. The film is a clock running downward from its own weight, the color bands marking where it is in that process. Near the top of the film, where the thickness has become very small, something changes. When the film reaches a thickness much less than a single wavelength of visible light, the cancellation condition becomes independent of wavelength. At this extreme thinness, all wavelengths of visible light meet the cancellation condition simultaneously, not because the film treats each wavelength differently, but because at this scale, the geometry produces the same half-wavelength offset for all of them at once. The reflected light goes dark, not one color removed, all colors removed. The film at its thinnest reflects nothing visible. It appears black against the colored film below it. A dark band at the top of the soap film, the colors continuing below it, the dark region spreading downward as the film continues to drain toward its limit. This dark region is not an absence of film. The film is still there, still spanning the space it was stretched across, still intact, still a surface of molecules holding together across the gap. What is absent is the reflected light. Every wavelength that arrives at this region finds the cancellation condition. Every wavelength arrives against itself. The surface that was reflecting a moment ago is now reflecting nothing visible from this side. The film is present. The reflection is not. The light that entered from the other side continued through. It did not stop at the dark region. The cancellation removed it from the reflected path, which means it completed the transmitted path. The energy that would have appeared in the reflection appeared instead in the beam continuing through the film in the original direction. What looks like extinction from this side is, from the other side, the light that passed without returning. The same energy, the same wave, moving in the direction the geometry of the film permitted. The dark band is not where the light stopped. It is where the light did not come back. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. The window glass holds its film in the frame. The night outside has not changed. The street lamp at the end of the block sends its light toward the glass at the angle the distance and position determine. At the thicker regions of the film, the light arrives, divides at the outer surface, reflects from the inner surface, and the two reflections meet. Some wavelengths adding, some cancelling. The balance between them set by how far the inner path exceeded the outer. At the thinner edges of the film, fewer wavelengths can add. More of them arrive in the state that cancels. The reflected light reduced further toward the dark condition the soap film reaches before it breaks. The glass is in the frame. The light is arriving. At the outer surface, the first reflection leaves immediately. At the inner surface, The second reflection begins its longer path, through the film, back up to the outer surface, into the direction the first reflection already took. They will meet at the surface when the extra distance is crossed. At the thinnest part of the film, the condition is being met continuously. Every moment that light arrives from outside, the geometry of that thin region produces the offset that cancels. The outer reflection leaves the surface. The inner reflection follows its longer path and arrives in the opposite state. They meet and reach zero. The light that left the street lamp, that traveled to the window, that entered the film and divided, that light is in the glass now, in the beam continuing through, carrying what the reflection could not carry, because the reflection used itself to reach zero. The glass holds the condition in its surface. The light keeps arriving. The film that built on this glass built without design. The oils arrived when the window was touched. The hand pressed against the glass to push it open, the finger tracing the condensation in winter, the contact so brief and so ordinary that it left no impression on the person who made it. The particulate arrived on the air. The fine suspended matter of the city carried against the glass in the damp months, adhering in the places where the surface held moisture, settling in the places where the air moved slowest. Each addition built on what was already there. The film that exists now is the accumulated record of all of it, not designed to produce any particular cancellation, not constructed to make any particular color disappear, but producing both as a consequence of what it is and how thick it grew. The film does not know what it is doing to the light. It presents a thickness. The thickness presents a condition. The condition produces the cancellation. The cancellation redirects the energy. This sequence does not require the film to intend it. The film is a surface. The light arrives. The geometry does the rest. The window has been holding this condition since the film built to its current thickness. Every night the street lamp has been on, the light has been arriving and dividing and meeting and cancelling at the thinnest edge. The result has been the same each night, the same geometry, the same offset, the same zero in the reflected direction, the same continuation in the transmitted. The film has not changed enough to alter it. The light has not changed. The condition persists. In the thinnest part of the film, light is still arriving against itself. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. When night falls, the archive remains. Some minds do not fall asleep by being told to stop. They need something quiet enough to follow. Before the light comes, the window is wet, not from rain. The sky has been clear since midnight, the air still, the stars visible through the glass. The wet is on the inner surface of the window, not the outer. Fine droplets, close together, covering the glass from the lower edge, to a line that runs across the pane at roughly the height where the air in the room began to stratify during the night, the warmer air rising, the cooler air settling toward the floor. Below that line, the glass surface has been in contact with air that was cool enough to release its moisture. Above it, the air held what it had. The window did not collect this moisture in a single event. Each droplet arrived molecule by molecule over the hours of the night. As the room cooled, the air near the glass lost its capacity to hold water vapor at the rate it had held it at the warmer temperatures of the evening. The capacity of air to hold moisture falls as the temperature falls, not dramatically, not all at once, but continuously, each degree of cooling reducing what the air can maintain in suspension. At some point during the night, the air near the glass reached the temperature at which it could no longer hold all the moisture it was carrying. The excess left the air and arrived at the nearest surface. The droplets that are here now began forming hours ago. The first molecules arrived at the glass when the temperature at the surface first crossed the threshold, the point at which the air's capacity to hold moisture dropped below what the air actually held. The surface was the trigger. The cold glass offered a place where the transition from vapor to liquid could begin. Once the first molecules arrived and adhered, the surface became slightly warmer at that point. The energy released by the transition itself, a small amount, quickly absorbed by the glass. The next molecules arrived at a slightly different point, or when the glass had cooled again to the threshold. The pattern of droplets on the glass is the record of this process, where the surface was coldest first, where the air was most saturated, where the first molecules found the conditions they required to make the transition. The glass is a map of the night's humidity and temperature, written in water on its inner surface, still present now because the air in the room is still cold enough to keep it there. The droplets are not moving. They are at equilibrium. The rate at which molecules are still arriving from the air is matched by the rate at which molecules are leaving the droplet surface and returning to the air. The droplets are not growing and they are not shrinking. They are holding the state the current temperature and humidity require. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. On the windowsill, there is a glass of water. It was left there last night, placed on the sill and not moved. The room cooled through the night. The water in the glass cooled with the room, losing heat through the glass walls of the container to the air surrounding it, the temperature of the water dropping toward the temperature of the air as the night progressed. By the hours before dawn, the water has reached the temperature of the room. The same cold air that condensed moisture on the window has been in contact with the glass on the sill, drawing the water's temperature down with it. The water is cold, colder perhaps than it appears. The glass contains no ice. The water is still liquid, still clear, still moving at the rate very cold water moves when undisturbed, which is very slowly. The convection currents from the cooling now absent because the temperature has equalized. The water sitting in the stillness that deeply cooled water settles into when there is nothing to disturb it. Water has a freezing point. Below that temperature, the arrangement that water molecules take in liquid form, the loosely associated, constantly shifting structure of liquid, becomes less stable than the arrangement they take in solid form. The energy of each molecule is not sufficient to keep breaking and reforming the bonds that liquid requires. The lower energy arrangement, the crystalline structure of ice, becomes the state the molecules are tending toward. But tending toward is not the same as reaching. For the crystalline structure to begin, the first small group of molecules must arrange themselves in the ice pattern and hold that arrangement long enough for the next molecules to join it. This first cluster, the nucleus, is where ice begins. Without a nucleus, the water molecules continue in their liquid arrangement even below the freezing point. They are in a state that is thermodynamically less stable than ice, but they have not yet found the beginning. The water in the glass may be below the freezing point, not far below. The room is cold, but not a freezer. The glass on the sill exposed to air that is near, but not dramatically below the threshold. But the pure water in a clean glass, undisturbed, can remain liquid at temperatures somewhat below the nominal freezing point. The glass has no visible scratches on its inner surface. The water was poured from a filtered source and carries few dissolved particles. The air above the water is still. Nothing has provided the surface, the roughness, the particle, the disturbance that would give the first cluster of ice molecules a place to begin. The water holds, not by resisting. The water is not resisting anything. The molecules continue their motion at the rate the temperature allows, which is very slow, each one moving a shorter distance before changing direction than it would at higher temperatures, the whole liquid less mobile, more viscous, closer in its behavior to the solid it is approaching but has not yet become. The water holds its liquid state because the condition for leaving it has not been met. The nucleus has not appeared. This is not a stable state in the sense that the water will remain here indefinitely. Any disturbance is a potential nucleus. The tap of a finger on the glass, a vibration from outside, a particle in the air landing on the water surface, the scratch that isn't visible but is present at the molecular scale in the glass surface. Any of these can provide what the water is waiting for without knowing it is waiting. The place where the first molecules of ice can arrange themselves in the hold. Breath enters. Breath leaves. Between breaths, the air holds its density. If the nucleus appears, the change will seem sudden. An observer watching the glass would see nothing, and then ice spreading from one point outward, the crystalline structure propagating through the supercooled water at the rate the water's temperature and the available molecules allow. The change from liquid to solid would happen faster than any process visible in the glass up to that moment. It would appear to the eye to be an event, a sudden transition, a before and an after with no process visible between them. But the process was there. The water did not arrive at the moment of freezing without preparation. Every degree of cooling that brought the temperature below the threshold was preparation. Every hour of the night during which the water sat in the cold air, losing heat through the glass walls, approaching the state in which the crystalline arrangement would be more stable. All of this was preparation. The nucleus will not create the conditions for freezing. It will only satisfy the final requirement of a transition that has been accumulating since the water first began to cool. The change was sudden only to the eye. The condition had been moving toward it all along. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. As the light begins outside, the room begins to warm. Not quickly. The air outside is still cold. The sun still below the horizon. The first light, the diffuse brightening that arrives before the source is visible. But the heat that is coming is coming. The temperature outside beginning its slow rise. The air of the room beginning to receive what the warming day will bring. The glass on the windowsill receives the first light on its surface. The water inside it begins to warm, slowly, at the rate the air allows, the same gradual process that brought it down through the night now running in reverse in temperature only. The water that warms in the glass this morning is not the water that was poured last night. Some of it is. The bulk of the liquid, the molecules that did not leave the surface during the night. But the glass surface has been exchanging molecules with the air all night. Some molecules leaving the water surface and entering the air. Some molecules from the air arriving at the water surface and joining the liquid. The exchange was slow, the temperatures cold, the rates low. But it was continuous. The water that greets the morning has a slightly different composition from the water that entered the night. The droplets on the window begin to change. As the room warms, the air near the glass recovers its capacity to hold moisture. The temperature at the glass surface rises. The equilibrium that held the droplets, the balance between molecules arriving from the air and molecules leaving the droplet, tips. More molecules begin to leave the droplet surface than arrive. The droplets shrink. They do not disappear all at once. The largest droplets persist after the smaller ones have vanished. The droplets at the warmer upper region of the condensation zone clear before the ones at the cooler lower edge. The line that marked the boundary between the dry upper glass and the wet lower glass descends as the room warms, the condensation retreating downward toward the coldest region of the pane, the last droplets holding at the bottom edge where the glass surface is still below the temperature at which the air can reclaim them. The droplets that are gone did not disappear. The molecules in them return to the air. Individually, one by one, the same process of exchange that operates at every water surface at every temperature, now running in the direction that removes the liquid rather than building it. The molecules that were water on the glass are now water vapor in the air of the room, distributed through the air that the rising temperature has made able to receive them. They are present in the room. They are not present on the glass. Breath enters. Breath leaves. Between breaths, the air holds its density. The morning brings the same room back. The same walls, the same floor, the same position of every object that was there last night. The window is the same window. The glass on the sill is the same glass. The water in the glass is still water, still liquid, now warming slowly toward the temperature the day will bring. The room is returning from the outside to what it was before the night. But the room is not what it was. The air holds different moisture than it held at the start of last night. The exchange at every surface through the cold hours has redistributed the water in the room. Some of it condensed onto the cold glass during the night and now returning to the air. Some of it never leaving the air at all. The glass on the sill contains water that has exchanged some of its molecules with the air during the night. The window carries the history of its condensation in its surface. The oils from the glass surface microscopically redistributed by the contact with the droplets. The trace of the droplet pattern still present at the scale where the surface chemistry was altered, invisible to the eye but present in the material. Return is not reversal. The room that the morning recovers is a room that has been through a night. The surfaces have been through their night temperature states and are now warming through their morning temperature states. The water has been through its deep cooling and is now rising through its warming. The molecules have exchanged. The surfaces have changed by fractions. The air has moved through the states that the night's temperature and the morning's arrival required. What returns is the temperature. What does not return is the state that the temperature previously produced, because the state was not produced by the temperature alone, but by the temperature acting on a system that was already different from what it was the night before. Different by the molecule exchanges, the surface alterations, the accumulated fractions of change that each night deposits in the surfaces and the air and the water before they move on toward the next condition. The room is the same room. The room has never been this room before. In the glass on the windowsill, the water is still at the edge. The nucleus has not appeared. The crystalline arrangement has not begun. The temperature is rising now, moving away from the threshold, the water warming back toward the unambiguous liquid state it will occupy through the day. The moment of potential transition is passing without having occurred. The water will not freeze this morning, the supercooled state giving way not to ice but to warmth. The edge the water stood at, through the cold hours receding as the day approaches. But the condition that brought the water to that edge was real. The hours of cooling were real. The temperature below the threshold was real. The absence of the nucleus was not a failure of preparation. The preparation was complete. Everything was in place. The final condition, the one the water could not provide for itself, did not arrive. The archive holds what the night produced, the condensation that crossed the glass and returned to the air, the water that reached the edge of its transition and was turned back by the morning, the surfaces that received the night's temperature and will carry the fraction of its effect into the day. None of these were events in the sense of things that happened and were complete. They were states that moved through their conditions and arrived at the next conditions, the water cooling, holding, beginning to warm, the droplets forming, holding, beginning to leave, the room receiving the night and returning it to the morning in a form the night altered. The change that did not happen to the water in the glass was not an absence. It was the condition running through the edge without crossing it, the full preparation present, the final requirement unmet, the water arriving at the threshold and passing through to the other side as water, carrying the thermal record of the approach in its current temperature, in the rate at which it is now warming, in the slight difference between what it was poured as and what it is now. The water in the glass is warming. The droplets on the window are leaving. The morning is arriving at the surfaces of the room at the rate the warming air allows, and the surfaces are receiving it at the rate their current state permits, and the exchange that the night set in motion is continuing into the day in the direction the day requires. The condition is always moving toward the next condition. The change was sudden only to the eye. The condition had been moving toward it all along. True wisdom cannot be captured in words. It is found only in the silence between them. Breath enters, breath leaves. Between breaths, the air holds its density. When night falls, the archive remains.